Hello and welcome to the most recent short interview for the IATiP community. So today I'm here with Ian Phillips, who works for Anua Clean Air International. And I wonder, Ian, please may you introduce yourself and your background, please.
Yes, okay. Thank you very much. My name is Ian Phillips. I'm a chartered engineer. I've spent many years in this area. I worked with Bord na Móna initially for 28 years, and we developed this technology and set up a business originally, a small business unit within Bord na Móna, which basically at the end of 2015, Bord na Móna decided to exit the business area in its entirety. And we bought out the technology rights and the rights to re-establish the business, which we spent the last 3 or 4 years doing. I've been involved in, over that period, in the two elements, well, the different aspects of the business. I was involved in the original development of the technology, and then I was involved in the business development projects to go into different markets and to open up those markets and to expand the application of basically biological air filtration technologies for treatment of odors and what they call VOC or volatile organic compounds or solvent emissions. So basically we treat low cold emissions from mainly from municipal wastewater, municipal solid waste, and from industrial wastewater treatment facilities, and some industrial emissions, low cold emissions containing solvents and very specific odorous chemicals. A lot of the work that I've been involved over that period of basically taking what was very considered almost a black art initially, to try and apply scientific principles in terms of sizing and understanding how these systems work, and then increasing the application, both in terms of industry and in terms of dealing with high strength and more difficult airstreams. So we've basically taken a soft technology, if you like, and expanded it, and we've gone in and competed with more difficult technologies. And we've continued on that journey, and we've continued on that journey since we've left Bord na Móna and gone on to develop new processes, and we're in the process of launching those now and marketing them internationally.
Excellent. Okay, so could you talk to me a little bit about the innovation that's relevant for the Irish aquaculture community, please?
Okay, so our value proposition as a business is built around offering best-in-class solutions. By that we mean the best performing solutions in the biological filtration arena, which provide the lowest cost treatment when we look at the full life cycle cost. We wanted to focus on using recovered materials where possible. So in terms of the aquaculture industry, a lot of our work is either involved in dealing with inorganic odorous compounds with either sulfur or nitrogen groups, and when they're oxidized biologically to produce either nitric acid or sulfuric acid. So our interest in the aquaculture was the shell media, which is alkaline in nature and has the ability to support biology and be used as a filtration media, and also releasing calcium, so effectively forming a biochemical reactor. So our interest, and we were aware there was quite large quantities of shell available from that sector that was problematic in terms of its disposal. So obviously if we could generate a high value process, or potentially high value process utilizing recovered materials, it's a double hit from an environmental point of view, because that material would typically go into landfill, and we're using it as a valuable way to treat air emissions. And it also provides a relatively low cost solution to end users when compared with using chemical or thermal systems, which require either a lot of energy or a lot of chemical consumables. So that really, I suppose, that's one element of it. So, but it's really I suppose for aquaculture, there's a potential disposal route for a waste product that they have. There's also, we have done projects in that sector treating air emissions from processing of seafood and production of fish meal for the salmon farming industry. I'm aware of 4 or 5 different projects we've done internationally where we've treated air emissions either from wastewater treatment plants on seafood processing facilities, or treating air emissions directly from some other processes. So there's that element to it. So they're really and I guess, yeah, they're really the aspects that should be of interest to people, to your clients in the aquaculture sector.
Excellent. Okay. Would you like to show a couple of slides to illustrate the technology?
Just to give you an idea, specifically the innovations that initially this technology was developed in around 1990 using mussel shells, which were found to be the most effective in terms of providing high efficiency treatment. This is just a short clip really here just to illustrate the basic technology. So basically what we have is a bed of shells. We recirculate water through the media continuously, and we introduce an inoculum with an active biological ingredient in that. And that basically colonizes on the surface of the shell and forms a biofilm. We continuously recirculate the water, and then the air is passed. We generally go what's called co-current, so the air goes into the top of the filter and then passes down through the media through what's called a plenum chambers, just to equalize the air so it flows evenly through the media. And the air goes down through it. The offending chemicals that give rise to odor, which are generally either sulfur, nitrogen, or organic compounds, are stripped out into the water, and as the water trickles through, the microbes on the surface of the shells basically consume the contaminants. So when you have purely organic compounds, you just get CO2 and water as a byproduct. But when you have compounds like hydrogen sulfide or ammonia, they're oxidized, so they form either NO3 or NO4, which is nitric acid or sulfuric acid. The advantage with the shells for this is that they release calcium carbonate to neutralize that acid. And it means we can recirculate the water, and our water usage is low. In more conventional technologies, you're either introducing chemicals into a process like this to oxidize and neutralize, or you're using a thermal reaction where you're thermally oxidizing the chemicals, or you're using an absorption media like carbon just to capture it and you remove it and treat it elsewhere. So this is basically which I could call a environmentally friendly, very ecological solution, utilizing a natural material and natural biological reactions that take place naturally in nature. The shells are, for a variety of reasons, are ideal for supporting biological activity, and we get very high what's called elimination capacities, in other words, the amount of contaminant that's removed per cubic meter of filter per hour. This business originated in Bordemona, and we came out of Bordemona in about 2015 with it. And one of originally we worked with peat as the media, but the limiting factor with peat was the control of pH when we're dealing with these acidic compounds. And the low pH, you were restricted in terms of you lost treatment on some of the more difficult compounds. So hence our interest in shells initially, because they were an alkaline media and the shape of them was ideal for mass transfer, and it was like a scrubber packing at quite a high surface area per unit cubic meter. The limitation, I guess, with the mussel shell was two things, and we marketed that product for about 10 or 15 years. Was the availability of shells, because it's aligned with processing industry where they remove the meat and they're left with the shell as a byproduct. Lots of shells are sold live, so that there isn't huge quantities of them available. The second issue is the mussel shell by its nature is quite light, so the bulk density of the shells are about 280 to 300 kilograms per cubic meter. So that even though the media has a capacity to treat very high levels or very high concentrations, when it comes in, when we see high concentrations, the media life can be quite short. And typically if we go above 50 ppm, the media life would be as low as 1 to 2 years, possibly even lower at very high levels. And the market really was looking for a minimum media life of 5 years.
Okay.
So we sat down to look at this problem to see how we could overcome it, and our interest was to look at other shells, which we tested in a similar format, the likes of oyster shells, which would have a higher density, approximately double about between 400 and 500 kilograms per cubic meter. Scallop shells. In America, there was a clam shell available, cohogs, that are known as the colloquial term for them. Much higher density with bigger shells, and if you use them in a straight through format, the air was bypassing because the shells were so big and we weren't getting good contact and good treatment. So the innovation or the technology development we did was multi-stage. What we established was that at higher face velocity, where we pushed the gas through quicker with the bigger shell, we were able to get better removal. So by effectively introducing compartments within the filter and creating 2 or 3 stages with the same size unit, we're able to use these shells as a preliminary treatment to the heavier shells, and we polish through a final stage with mussel shell. So it's basically staging using different seashell species that are available and using the heavier shells in the first stage. By doing that, we were able to more or less double the lifespan of the media with the same size container. And the efficiency of the unit went from, actually efficiency improved, so our efficiency has increased from typically about 98% to about 99.5%. So there was a double win for the client. They were getting a longer media life and higher efficiency. And really the only extra capital cost involved was installing an internal dividing wall within the existing housing. So that's one innovation, and we've just been, within the last 6 months, we've been awarded our patents on that. So we have international patents on that, and our intention is to go out and exploit that commercially. The other piece that we did was for very high airstreams with H2S levels in the hundreds of parts per million. Again, our interest was very much looking at recovered media and looking at staging. So we had done some work initially looking at crumb rubber, which is crushed car tires, disposed of car tires that are crushed and made into a crumb particle. We knew, or we had established about 10 years ago, that it had a catalytic affinity for sulfur groups, but the typical removal would be quite low, about 30%. And there was zinc oxide present on the rubber, which meant that they weren't very friendly towards allowing a biofilm to attach. But we managed to overcome the biofilm one by using very high irrigation rate, recirc rate on the water. And we're now able to offer the crumb rubber as a preliminary stage and polish through shells in the second stage. And that really allows us to go into treating really difficult emissions in hundreds of parts per million. And again, that development was the subject of a second patent, because we also looked at using that process for treating biogas or landfill gas, which is huge levels of H2S. And the issue there on that one was not so much odor control or air pollution control. It was energy recovery from biogas. With very high H2S levels, the H2S does terrible damage to gas engines. So by effectively putting in a biotrickling filter to remove that, you can reduce the wear and tear in the engine and increase availability. So it's kind of a new business development project that we have. But we have completed the research side of it, and we've lodged patents on the patents that again have been awarded in Europe. So they're really the developments that we have. Is one would, for the air side, is a multi-stage using different grades of shells, or a combination of crumb rubber and shells. And for the biogas is using the crumb rubber again, all based on using recovered waste products from other industries. So really what we're after here is we've a soft solution that uses very little water, very little power. We use recovered materials as the filtration media. We get very high efficiencies. We can compete with conventional technologies that either use very high amounts of energy or high amounts of consumables. So that our life cycle costs, not so much the capital costs, but the life cycle costs, when you look at it over 20 years, the savings are significant. So that's really the background to what we're doing. And most of these innovations, I suppose, like most innovation, it's incremental. You're improving on original designs and optimizing designs, and you're facing new challenges, and to overcome those challenges, you're having to come up with new solutions.
Excellent. Okay, are there any other slides that you wanted to show, or would you?
That really is probably quite a good one from just a development point of view, just to understand how that learning curve. Like initially, when we looked at this in 1990, we looked at using the monofil. There was a peat product, so it could typically treat up to about 30 parts per million, and you could achieve about 95% removal. The single stage shell technology, which was developed in the early 90s, that really allowed us to push up to about 50 parts per million. When we went to the dual stage monoshell, then we could push up a bit more, and then we went to looking at using the different types of seashells, the oyster shells in combination. that allowed us to push right into the hundreds, and then the crumb rubber allows us to push into the thousands. So it's to give you an idea of, and if I put other conventional technologies against that, you get an idea in terms of So really what you've done, you've taken a soft technology that was originally had a very narrow application range, and through various innovations and developments, what we've more or less done is you're able to take in the full suite of applications if necessary, and compete on a much bigger pitch. Okay, so that's that one. Just to give you an idea of where we have done some of these. I guess over the last 20 years, like combining what was done when this business was within the Board Group and outside it, just to give you an idea, like this is, we have a sister company in Italy, Airclean, who are a 50% shareholder in our business, and we've worked with them for the last almost 30 years, and jointly to ourselves, and we've effectively put plants in more or less on every continent, and we've done the full suite of applications. The big areas that we work with are probably, in terms of application, wastewater. Municipal wastewater is by far the biggest application when we look at numbers of filters. In terms of airflow, when you're dealing with solid waste, municipal solid waste, and they bring it in either to transfer stations or to mechanical biological treatment facilities, or to anaerobic digestion facilities, which are becoming more and more feature, you end up with solid waste material in very large buildings, and you have to ventilate those buildings, so the airflows are quite large.
Yeah.
So those systems are quite big. So the solid waste is a big application for us in terms of not so much numbers of filters, but typically for wastewater treatment plant, a filter might be 20 cubic meters, but for a solid waste application, it could be 2,000 cubic meters. So these filters could be big, half the size of a football pitch. They can be significant in size. And then we'd have done a lot in the food industry, dairy and abattoirs, that type of thing, treating emissions from wastewater treatment plants. They'd be their most common applications. And I suppose, like, this is technology that was developed in Ireland, I suppose, and we're probably one of the few who's actually internationalized it and pushed it right around the world.
Yeah, very impressive. Would you mind stop sharing your screen then? Just by clicking at the bottom. That's great, thank you. So in terms of how this is interesting to Irish aquaculture, I wonder if you could tell me what your call to action is, whether you're looking to source shell from any of the companies that we're engaged with.
Yeah, we're I suppose a couple of areas. Obviously, if we expand this business out, the demand for shells get bigger, and the potential. If you look at currently, the big challenges facing the world at the moment, and on the one hand you have environmental, and on the other hand you have quality issues, we say. And more recently you have pandemics. But really what's becoming clear is that, the renewable sector, which involves recovery of product from waste streams or energy from waste streams, and all of these processes, they're there and they can be different, but a lot of them will generate air emissions that need to be dealt with. And not only that, I suppose if you couple in on top of that, then the way that different economies are choosing to look at trying to kickstart after this pandemic, the infrastructure, renewable technologies, power generation, it's kind of the obvious way for governments to on a big level to try and reboot economies, and we feel that there's big potential in this whole area, and there's potential to drive these technologies out around the world. The shell is a critical component. It's like the engine in the car. It's a critical component for us. Where we struggle to source particular shells, we've looked to adopt the technology so we can use we can use either other grades of shells which currently weren't thought usable, or we can use the crumb rubber as an upfront media to effectively extend the life of the shell from maybe 5 years to 10 years. But obviously, availability of the shell product is a critical issue for us, particularly if we want to look at expansion and growing this business significantly. And there's no doubt the potential is there to do it. So we would see, like, what we're trying to do is effectively, like where the shells typically would have been, there might have been a cost associated with disposing of them. We're trying to pay a certain price for them, so that at least there's some revenue stream for the producers. And then for the difficult shell where you have the meat in it, what we've tried to do is develop an in-vessel process where we convert skips, where we have a recirculating process there, and we can take them in and bio-recover them ourselves, and we would take those shells away free of cost rather than charging for them. So what we're really trying to create is a win-win scenario for all the stakeholders in this. We'd see the aquaculture industry as a key stakeholder in this business.
Excellent. Okay, thank you. So I guess just a quick nod to what's next then. You're obviously going for lots of patents. I guess you would probably like to engage with shellfish producers in Ireland. What's your aspiration for next stages in Ireland?
Yeah, well, I think, like, it's a good question. It's in terms of market development or markets that we'd like to go into more aggressively, and we're effective. I suppose we spent the last couple of years trying to get these patents over the line, trying to perfect the application that we have. We have a new facility, or at least we've taken a lease from Boardamona on one of their old workshop facilities in Port Arlington. So we have a capacity to, and we've moved our 2 production lines in, one for the peat and one for the shell product. So I guess our mission is around internationalizing this business and providing low-cost solutions to and optimizing the potential of the technology and the people that work for us, and as we see it. So the challenge really is in the current environment is to try and plot a course through that allows you to effectively trade and protect the business that you have, and to set a platform for growth in the future, and to manage that growth. And they're the challenges that we face. There is more developmental work to be done. There's optimization work to be done. There's value engineering work to be done, and there's market development work to be done. And it's really, I suppose it's a question of just plotting a course through that. We'd like to see it grow into an international business. What we spent the last 3 or 4 years doing, I guess, Boardamona, following these businesses were really suffered during the recession, obviously, because they were aligned with infrastructure investment, which more or less collapsed. So our mission over the last couple of years really has been to rescue the business and get it back on a sound financial footing. It's trading profitably at the moment, and we have the patents through, we have a home for the business. So the next stage is manage growth and to push it out internationally, but to do it in such a way that it's done. We've effectively done it organically, and I think our intention will be to continue that path. We have the basic building blocks in place. We're not heavily borrowed. We have partners in place all around the world. So what we want to do is basically allow the business to realize its potential. The best references for us are existing installations and existing clients where the technology works. So really that's the challenge is to manage it through the next phase and to allow the business realize its potential. So that's and I can't give you a definitive answer because it's like Brexit, we're all scratching our head looking at it and trying to figure it out. But I think we're all trying to find our way in a new world, but I've no doubt that I think that a lot of things that had to happen have happened in a shorter time frame, and I think that these types of businesses will find they'll find their flow, and they'll find how there'll be new ways of conducting businesses and transferring technology and realizing the benefits of these types of technologies for the greatest number of people possible. I suppose that's the vision, but it is about enabling and realizing potential, and that's what we're committed to. So I can't give you a definitive answer in terms of the roadmap because I've no idea. That's the truth.
No one knows it right now. But congratulations on achieving an international patent. I know that that's a challenge, and there's a lot of work that goes into it. But if any of the shellfish producers in Ireland would like to get in touch with you, how do they do that, and how do they find out more, I guess, please?
Okay, yeah, well, look, we have a website there, Anua Clean Air International, and we have a UK subsidiary as well, and then our Italian partners, Air Clean in Italy, have a detailed website as well. So all those websites will contain multiple information on references and applications, and on contact details and case studies, and there's plenty of technical papers as well that we have presented over the years. So there's no shortage of information there. They can contact us directly. We'd be delighted to talk. I know we're in contact with the number already, but I suppose the good news is that we're looking to ramp up, and even during this period, difficult as it has been, we're currently, we're probably shipping, I can't put an exact figure on it, but I would think we're shipping between 50 and 100 containers of media a year at least, so there's significant volumes of media being shipped, and that trajectory is on the upward curve, and I have no doubt that the potential for this is enormous. So particularly in a new world where air pollution is going to become, I think, very important.
Absolutely. Okay, well, thank you very much for your time. I really appreciate it, and I hope that people get in contact with you.
Okay, listen, thanks for that. Look, and hopefully it's been informative, and people will that they'll join us on the journey anyway.
That's great. Thank you very much.
Okay, thank you.